Okay, welcome. Hello, this is my period 6. It's still HESPA week. They're a little bit, their brains are a little fried, okay? This is fluids test review 6, okay? Now, on the board are several things. I have the density of water in 3 different ways. This is what we use. That's standard. That's metric. That's standard metric. That's SI, Systems International. That's what we use. However, this is used in chemistry, and this is also very important. This looks good, right? In other words, right, Mickey, how much do you weigh?
130 pounds.
130 pounds. Now, somebody take out their calculator and divide 130 pounds by 2.2. Why by 2.2? I'll speak to you while they're doing it, because it's 2.2 pounds per kilogram. So how many 2.2 pounds are in 130 would be 59.1. Can we just say 59? So you weigh, your mass is 59 kilograms, yes? So being that you're mostly water, right? Mostly water. You have a similar density to water, correct? Especially salt water. How do you know you have a similar density to salt water?
Because it's denser.
No? Yes? You float in salt water. You want to think, okay? You want to think. Because you float in salt water. So your density is going to be similar to water. Not exactly, but similar, okay? Right? So what can we say about Mickey's volume in liters if he's mostly water? Because, yeah, you have bone, which is not very dense, actually. Maybe 1.2, 1.3 tops times water. You have lungs, which are filled with gas, which kind of like, you know, helps to balance things out a little bit. Yeah. So what is Mickey's volume if he's close to that of water? Look at the board. Look at the board. What would his volume be in liters if he was mostly water? It's right there staring you in the face. It's staring you in the face. You know what it's saying? It's saying, hello, I'm here. Can you see me? I heard it. Did you hear it? I heard it. What's the volume? Well, it says 1 kilogram per 1 liter. So if he's 59 kilograms, what divided by... Well, I'm spilling everything right here. What divided by 59 kilograms will equal 1? Kelly's looking at me like, I have no idea. What divided by 59 will equal 1? 59, right? Kelly, you with me? Okay, so what if Mickey's mostly water? If he's mostly water, what is his volume in liters? They're stunned. They don't know. What is it in liters? Come on, tell me. We just said it. 59 liters, right? Yeah. So that can be very important. Hint, it's on the test and the quiz. If you're 59 kilograms, you're 59 liters, correct? Yeah. Yes or no? Yeah. You with me? Are you guys here today, or are you here? Okay. Kelly's shaking her head no. Okay. Emily, are you here? She's like doodling. Brian, they really are spent. They really are. How many people are like completely burned out for the week? Let me go home. They're all raising their hands. Kelly's raising both hands. She's surrendering. Okay. All right, now, let's do another thing. And that is that here's the density of Mercury. Okay? The density of Mercury. Yes? Okay. Well, the density of mercury is 1,360 kilograms per cubic meter. Correct? Is that right? No, it's this. I also have the electrician here fixing the intercom system. It's a crazy day. Okay, I'm sorry here, but this is 13,600 kilograms per cubic meter, correct? Do you understand that? Do you acknowledge that I made that change? Okay? Now, so I can also say that it's going to be 13 grams, 13.6 grams per cubic centimeter. I can also say that, correct? Yes? Or 13,600 kilograms per cubic meter, correct? All right, now, 1 atmosphere of pressure, this is not really drawn to scale. Well, maybe it's a little drawn to scale. That represents 0.76 meters of mercury. 0.76 meters of mercury. That would be not it. Okay. I don't have a meter stick. Could you give me a meter stick over there, please, Brian? So 0.76 meters of mercury, that represents 1 atmosphere of pressure. Okay, can you see me? Okay. This is right, excuse me. Right here. So here to here. That's 0.76 meters of mercury. So if I had a dish of mercury, I'm going to erase, can I erase this? Is that all right? Is that all right? I'm going to erase this? Okay. So if I had a dish of mercury, okay, and I filled a tube, closed at one end. Let's say this is a tube. Okay? Let's say it's a glass tube, closed on one end, right? And I filled it completely to the top with mercury. This is the top. This is closed right here, okay? Is that all right? Okay. And I filled it completely. This is the top, right? This is the closed end, right? This is the open end, right? So I fill it with mercury, glug, 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 right? And I put my finger over it, correct? Right? And I turn it upside down, and I put it in the dish, okay? I put it in the dish, and I let go, okay? I let go. What'll happen is, let's say this is it. This it will settle down. This will be a vacuum, right? And the height of that column will be 0.76 meters. Do you get that? Yes? Do you understand what I did? Yes? Okay. Eudometer, okay, closed end. This is closed, this is open. Fill it with mercury, glug, 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 glug. Put my finger here, right? Then I put it into the mercury, take my finger away. This will fall. So the height of that will be 0.76 meters, correct? Of mercury. Now mercury has a density of 13,600 kilograms per cubic meter, and it has a density of 13.6 grams per cubic centimeter. Yes? Now, an interesting little side note. You ready? How tall would this column be if it, instead of being filled with mercury, it was filled with water? Water's lighter, so you can push it up, right? The atmospheric pressure is pushing down. Right? Let's represent it like this. Pressure is pushing down, right? It's pushing down on this pan of mercury, correct? And it's pushing it up. Yes? Yes? Okay? So the mercury is being pushed up to right here, correct? Now mercury is really heavy, isn't it? Hard to push that up. So what happens if it were water? What happens if it were water? Well, the density of mercury equals 13,600, and the density of water equals 1,000. How much more dense is mercury relative to water? How much more dense is the density of mercury relative to water? Divide it. 13,600 divided by 1,000. What is it? What is it?
13.6.
What is it?
13.6.
13.6, right? So mercury is 13.6 more 13.6 times 13.6 times denser than water. You see that?
Yeah.
Mercury is 13.6 times more dense than water, correct? 13 times, I can speak English, okay, I'm sorry. 13.6 times more dense. Okay? I can speak English very well, okay? It may seem different, but I can speak English goods. Yeah? Okay? Very good? Okay. So, mercury is 13.6 times denser than water, correct? Right? And if it were 0.76 meters, this is meters, right? Meters, right? Correct? That's what that height is, correct? So 0.76 times 13.6 is 10.3 meters. So the column of mercury is 0.76. If it were water, it would be what? It would be what?
10.3.
It would be what? 10.3. Is that what you said? It would be 10.3. You get it? Easy? So what did I just do? I simply said the density of mercury is 13,600 kilograms per cubic meter. The density of water is 1,000 kilograms per cubic meter. Didn't I say that? I said that mercury is 13.6 times denser than water, correct? And I said that the normal atmospheric pressure will push mercury up a tube 0.76 meters. Did I say that? I said that, right? So if water is 13.6 times denser than water, and the atmosphere pushes mercury up 0.76 meters, it will push water up 10.3 meters. Correct? Do you get it? You understand? How am I doing? Kelly, you still all right? You all right? Okay? You're the only one, Matt, that actually looks like he's paying attention. Do you get it?
Got it.
He looks very good today, very sharp, very good. Excellent. All right? Number 6, done? Are we done?
Yes.
They're going, oh, please be done. Okay? Bye.